All right, we're taking a look at finding the derivative. This time, I'm going to find a general derivative. And what I mean by a general derivative, it's going to be an expression which will find the slope of the tangent line at any point on the function. So let's take a look at what I mean by that. Let's say I have f of x is equal to the square root of x plus 4. So if I took a look at that graph, over here at -4 I would have 0, and at 0 I would have 2, and at 5 I would have 3. So if I looked at this graph, it looked like a graph that's kind of headed in this direction. Okay, it's a curve. It's kind of going like this. It's kind of a bad drawing on my part. And so I'm actually going to compute the tangent line at this point and the tangent line at this point. So this value is 0, this value is 5, and I'm going to figure out what the tangent lines are those. So they could be at any point. Actually, I'll even do one at -3. So I'm going to compute the slopes of the tangent lines at x equals a -3, at x equals 0, and x equals 5. And so I'm going to come up with a general one. And this particular classic definition is the limit as delta x approaches 0 of f of x plus delta x. So that's my first input is x plus delta x minus f of x all over delta x. So on this one I'm going to I have the square root, so I have the limit as delta x approaches 0, and I'm going to have the square root symbol here, but instead of x, I'm going to be putting this x plus delta x in there. So I'm going to have x plus delta x. Now that's what I substituted in for right here, plus 4, minus the square root of x plus 4 all over delta x. Well, one of the techniques you learned from a previous chapter is when you have square roots like this to multiply by their conjugates. So the conjugate that I'm going to multiply the top and bottom is going to be the square root of x plus delta x plus 4 plus the square root of x plus 4. And I'm going to do the same type of thing on the bottom. Square root of x plus delta x plus 4 plus the square root of x plus 4. Now when I multiply that out, the reason I multiply the conjugates is there's no middle term, and it's simply going to be the product of these square roots and the product of these square roots. So the square roots are eliminated in the numerator. And I'm going to have x plus delta x plus 4 minus, now I'm going to put in parentheses x plus 4, and in a bit I'm going to distribute this minus 4 all over delta x, that's this thing right here, times the quantity, the square root of x plus delta x plus 4 plus the square root of x plus 4. And that's going to give me the limit as delta x approaches 0. And I'm going to have x plus delta x plus 4 minus x minus 4 all over delta x times this massive expression down here. And I'm going to have some things eliminate. This x is going to cancel out with the minus x, and this plus 4 is going to cancel out with the minus 4. And what I mean by cancel, these are going to become 0. So now I have the limit as delta x approaches 0 And all I have left in the numerator is delta x. And what I have in the denominator is delta x times the quantity, the square root of x plus delta x plus 4, plus the square root of x plus 4. Now again, I'm going to have some simplification, and right here, these are going to simplify to 1. So now I'm left with the limit as delta x approaches 0 of 1 over the square root of x plus delta x plus 4 plus the square root of x plus 4. Now my limiting process, what's going to happen is I'm going to have substitution, and this value right here is going to go to 0. I'm going to substitute 0 in there, so that when I take the limit, I'm going to have 1 over the square root of x plus 4. Where did the delta x go to? It became 0 as I approached 0. Plus the square root, this is a plus sign, the square root of x plus 4. And I'm going to have 1 over 2 times the square root of x plus 4. Now, what that's going to give me is the formula, the derivative formula, that if I know x, I can determine the slope of the tangent lines. Well, I know x here. I know x is a negative 3. So if I plug a negative 3 in there, the slope of my tangent line, my first tangent line, when x equals a negative 3, and I'll do this funky notation, is I'm going to have 1 over 2 times the square root of a negative 3 plus 4. Well, negative 3 plus 4 is 1. The square root of 1 is 1. 2 times 1 is 2, so I get 1/2. So right here, at a negative 3, which would be here, I would have a tangent line at this particular point that looks like this. And the equation of that tangent line would be y sub t is equal to, what I have a slope of 1/2, x minus a negative 3, which is x plus 3. And if I plug in a negative 3 in here, I'll get 1, and the square root of 1 is 1, so y is 1. So that's the equation of that tangent line. Now I'm going to have another one. Now notice, well, I'll try to draw it differently. It's a little flatter, isn't it? So this tangent line is going to be y sub t, this one right here, at 0. I'm going to have a slope. So in here I'm going to have, for this one, I'm going to have the slope of the tangent line when x equals 0. I'm going to have 1 over 2 times the square root of 0 plus 4. Well, that's going to be 4. The square root of 4 is 2. 2 times 2 is 1/4. So I have something that's not nearly as steep. And so that particular one is going to be 1/4 times x minus 0. And if I put 0 in there, I get plus 2. Then I have this one right here that's even flatter because it's not growing as quickly. That tangent line right here, my messy tangent line, is going to be y sub t equals. Now let's take a look at here. So I'm going to have the slope of that tangent line at x equals 5. And so I'm going to have 1 over, again, I'm using this formula, of 5 plus 4, because that's my x right here. Well, 5 plus 4 is 9. The square root of 9 is 3. 2 times 3 is 1/6. So I'm going to have 1/6 x minus 5 plus, and if I put 5 in here, I get 9. The square root of 9 is 3. Remember, f of x gives me my y values. So this is the classic limiting process to get the general form of a derivative.